Hello. Hi, how are you? All right. Looks like Morgan and Jesse are here, and Ashu's here. Welcome. And Barshan is here. All right. Well, let's get started. So, welcome. Uh, I guess we can start with Barshan's update. I know Jesse probably also wants to present his things on public speaking, which we've kind of put off for a couple weeks. I have a feature towards the end, and I don't know if Ashu has anything she wants to present or Morgan, but we can do that as well.
I don't have any presentation to present right now, but I want to just inform that I have been updating that GitHub report that I have shared earlier, and I will share it in 2 or 3 days in the channel. I am
Okay,
working
that
for the project.
all right. That sounds great. Thank you. I look forward to it. All right, Barshan, are you there?
Hello, am I audible?
Yes.
Yeah, okay. So I was busy fixing some bugs actually with the model, and there were some bugs. So it's good that it took 2 weeks, like fast forwarded it. So I expected some bugs. Also, I did put up a blog to explain all the three modules easier because I thought that the last time it was a bit mixed up and a very technical side. So I put it onto simpler terms in my blog using a student friendship example where I put the embryos, the cells as friends, and the relationship between them as a friendship. So yeah, so based on that, I noted down how each module was. Now I have put together a few images also, which are yet to be uploaded into the blog, so it's taking a bit of time. So maybe I
Okay.
can present it a while after. Maybe a few talks if anybody else wants to present. After that, I can do that.
Okay, that sounds good. Yeah.
Also, I'll put a pull request at the end of this week with the bugs all fixed and everything.
Oh, that's good. Yeah.
Yeah.
So the pull request you made has like you just have to update that pull request or update those files.
Yeah. Just
All
update
right.
those.
Yeah. Let's see. All right, so yeah, this is the pull request Barshan was referring to. This one at SGL EAM and model layers. So this was from earlier this week, and I accepted it. So that we have our commit here. Just have some files in there, so we'll be updating the files as appropriate. And then I look forward to the blog post. I think that's nice to have it like kind of explained very simply. Um, yeah, so that sounds great, Barshan. Thank you. Okay, Jesse, are you there?
Yes, I am, but I am not really in a. I'm basically walking around still, so I'm
All
not
right.
really ready to do anything right now. In like 10 or 15 minutes, maybe more so, but not at the moment.
Okay, that's fine. Morgan, are you there, or you have anything you want to discuss?
I am here. Excuse me. Not sure what the. um, yeah, not any particular topics, but uh, happy to happy to talk about agentic coding.
Yeah, we
Yeah,
might.
still lots of experiments ongoing in terms of data free analysis of model weights and some interesting physics around that.
So, what do you mean by that? Data-free modeling.
Yeah, so I mean, where you're modeling the weight matrices, doing analysis of the weight matrices to try and um, have some sort of metric of training completion, you know, um, uh, or kind of like weight quality, and you know, so like looking, you know, started using GPT-2 and fine tuning on particular tasks as you know, kind of the inputs to generate some of these weight matrices, right?
Yeah.
And then using Weight Watcher to be looking at that, trying to understand better what Weight Watcher is doing. You know, how does renormalization group become relevant for this kind of um, eigenspectrum analysis?
Okay. Yeah, I'll have to look into that. That sounds interesting because I'm thinking about like some of the things we're doing with connectomes, like with C. elegans and with Brainberg vehicles. And we have weight matrices, and I know that they're not like the same as a neural network weight matrix, but it would be interesting to do things like that with those kind of
Well,
would essentially.
that's a yeah, so that's a separate thing, but is you know, overlaps, and I am definitely, you know, I'm still trying to find a good approach to come at uh, kind of Danny Bassett like network control theory, but really thinking about, you know, finding network architectures, uh, um, and yeah, been looking at like differentiable network search architecture techniques, architecture search techniques.
Yeah.
Um, so you know, that was like literally checking on some experiments this morning. So
Right.
not quite sure. Yeah. So um, uh, yeah, and some failed experiments. Well, or I should say, I was able to um, falsify some, you know, some people's attempts on finding on quantum architectures, which is probably no surprise, right?
Yeah.
Yeah. uh, but uh, but but the one interesting thing that came from that was this differentiable architecture search that I want to see if how that connects to kind of this, you know, kind of network neuroscience problems.
Right. Yeah. Yeah, I think there's a lot of exciting connections between like network neuroscience and connectomes and like neural networks, especially when you start getting into the weight matrices and thinking about what those represent.
Yeah. So I'm gonna try writing that up and sharing with Charles Martin's, you know, community. Um, yeah, everybody's got their own Discord server these days.
Yeah.
Um, and yeah, get some feedback. I'm sure I will learn a lot, and he'll probably you know, have some good suggestions for me in terms of directions on this. Um, I'm also trying to connect it to, you know, trying to see like what do, you know, again with like the MedArc people, you know, how do how else do researchers try and approach this problem, or uh, and especially in cases, or like how to do, you know, how this relates to kind of like data augmentation, and when you do have a small amount of data, you know, what you can do to try and get matrices into a form that looks better, and hopefully does better, you know. um, uh, yeah, so this is, you know, part of the extended program of just trying to learn this, you know, new form of machine learning. as opposed to my classical background. It's a coded way of saying mold, um, but yeah.
Well, that's great. Yeah, I would like to talk more about that maybe in a Saturday meeting if you want to present that at some point. That'd be great.
Sure, sure. Yeah. I mean, it's yeah. It's nice to look across as well. I mean, just in terms of by looking at multiple foundation models, just seeing the variety, you know, that there is actually a kind of wide set of responses um, from these, at least applied to neuroimaging data. Um, so yeah, lots to learn, obviously, for me.
Yeah. All right. Thank you again. So then it looks like Barshan is ready to present.
All right. So basically, we had three modules, which is the EAM. So I'll just start explaining like this. So EAM is the one that has the attention scores mapped. So I am taking a like I'll just out a legend. So here the school is basically the whole embryo that we have, and the cell and the students are the cells, and the cells have this connection between them, which we cause like a friendship between the friends over here. So if you take a snapshot of the school at one instance, the EM is the part of the model that asks which friendships are holding everything together right now. So basically, let's say we have this number of cells and they are having a relationship with each other. So it just takes a look at one moment and then sees that which connections matter the most. And then they are removing the connection which has the least number of cell which has the least number of connections. And then again, they're scoring them, and to that they are seeing that which of the at that moment which cell is the most importance for each connection. So this will temporarily remove all the cells which has the least number of connection, and then have a new subgraph, and which again will go through this importance score theory. So for example, if Alice and Bob are the two students who bridge the drama club and the soccer team, AM will highlight the friendship as extremely important because it structurally connects two otherwise separate groups. So if there's two groups like the rear part of the worm and the brain part of the worm, and one cell connecting both of this, or maybe so that is an important cell which is getting after the division, which is going to two different parts of the worm. So so it assigns this high attention score to that physical cell to cell contacts that are critical to the embryo's shape at that moment. So next is the DRL, which is the relationship tracker, which is the edge. It tracks the edges of the cell, and the DRL knows that a connection at time t depends on what happened at the state before that, which is t-1. So it uses these gates. So in the theory of attention, we have all these gates like the recurrent neural network. We have this reset gates and update gates and like forget gate. So these are needed because it can't store all information together because it increases the computation. So in order for that, we have to decrease, like we have to let go of some information which is not really required or not really important, and then compute it on the new information. So the DRL works on that mechanism. So there's this gated mechanism which let the information stored to know how it's stored or why it's stored and how important it is. So uh, okay, so let's say we have two cells which had this connection, and but after one state they didn't have a connection after that. So it acts like a memory tracker. It says that if it's drifting apart, if the cells are drifting apart from each other after this division, and then it will take the DRL structural map from that and then revise the importance score again. So we have a lot of the scores coming in together from all kinds of new theories, which will give us more information later. So the DNL is the node up. It takes care of the node, which is like a cell, and see that after this division, how did the inner features of the cell change? Like how did the location of the cell change, or how did the maybe some other feature of it change. So it will track that after a certain division or after losing this many connections or after gaining this many connection, how did it change in the next state. So that is like the personal growth updater, which is the DNL. It will check like how each cell updates itself after a certain state. So then it blends in the new information which it had of the past cell using the temporal gates, and then it will again pass this information into the EAM to the next state. So this will go in a cycle, and then we have a lot of information like scores from the attention, and we have the edge centric scores from the DRL, and the DNL will give the information about how the cell evolved. So this all will go together and will make the model more explainable after the whole divisions or the whole time step has been covered. Uh, so yeah, that's it. There are a few examples which I've put in a simple way so people can understand. Uh, Other than that, SGL is mostly because it from the paper what it was evident that it is mostly used where structures appear and disappear and the relationships change from time to time, and the cells themselves are changing by the other cells they interact with. So these three modules are very efficient in calculating those edges, changes in the edges, and the changes in the cells. So that's just the whole summary of the SGL model that we have.
Oh, that sounds great. Yeah, thank you, Barshan, for that update. Did we have any questions about that? I like the way you kind of phrase this or couch this in terms of like friendships and things like that. So, yeah, I think this is yeah, pretty good. So you're going through the different steps. You're going through the EAM, the DRL, the DNL, and then the outcome.
Yeah, these are
And
all focusing on different one is focusing on just the cell and one is focusing on the relationship with all the other cells.
right,
So
right.
one is just focused at how is the cell changing over time, just one cell, and the DRL is focused on which cell is getting changed, like the connections which are losing the connections and the gaining the connections. Those are taken care of the by the relation DRL. And the EM
Okay.
basically it checks like just takes a snapshot of just one time step, and then it checks that if I remove this node which has only two connections, then which nodes are more important in that snapshot. So it creates an importance variable.
All right. So it's basically about determining the importance of any one cell given all the other cells.
Yes.
All right. Yeah. Yeah, that's great. All right.
It can also
Yeah.
differ from just a cell or even a division, like how important is a division than the other divisions or something.
Yeah. 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 Because that's important. I mean, when you say a cell is important, you have to consider its lineage because the cell isn't always going to be there. It's going to have daughter cells, and those divisions are going to be just as important as the
Exactly.
standing cell. Yeah. All right. Yeah. Thank you. So, did we have any other comments about that? Okay. And so this coming week, you're going to be fixing some bugs, and you also have another pull request at some point. I mean, for this week's work, what's your plan for this coming week?
I think I'll start training the model with the data, and then maybe look a bit into the visualization steps, like using
All right.
Mapari or maybe something uh, other than explore more about the visualization things. If
Okay.
there
Yeah,
is
it
any
sounds
other
good.
language, yeah, the exploring shouldn't take much time because we can I can just surf the internet and see which is the modern visualization techniques that are available, and there are pretty much a lot of them right now. So I have to just hop into the computational biology sites and stuff.
Yeah. You might look back through the repository at some previous GSoC work, especially last year and the year before, because we did do some visualization there. And we didn't get it exactly the way we wanted it, but that might be a good starting point.
Yeah. I mean, also I
Yeah,
can talk to Mehul and all. I communicate with him regularly.
yeah, it's good. Um, yeah, Mahul, of course, probably knows a lot about that.
Yeah.
Yeah. All right. All right. So yeah, Jesse says good blog. So he's still kind of in transit. So why don't I present on the thing I want to talk about today? So we've been kind of talking about between this meeting and the Saturday meeting about frontier models and just kind of observing what's out there and talking about them. And I've always been kind of flummoxed by the definitions here. So, like, what is a frontier model? And, is it just a really big model that large companies use to say this is the way to go? And they try to, make sure that everyone falls in line? Or is there a value in having a large scale pre-trained model that you can kind of draw from as a standard? And so it strikes me as like it's true. A little bit of both is true. And so that's my take, and I'm a little bit jaded about it. But I want to talk today about open source frontier models because frontier models, it's a kind of a buzzword, and then it's becoming more. They're becoming more prominent in different fields. And Morgan's always talking about the neuroimaging frontier models, and that's state of the art. So I want to go over. So I have two articles that I found on open source frontier models. Actually, so I'll start with this article here. It's an online article from Coder, which is a site, and this is called "Open Source Frontier AI Models: Why They're Essential Amid the Intensifying 2026 AI Race." So, as we know, their companies are kind of racing to sort of, dominate the field or at least have a significant footprint in the field. And so there's a lot of money at stake, of course, but there's also a lot of influence on the course of developing these models. And so, again, we have different companies from Silicon Valley, different Chinese labs that are doing work, and they're all pushing frontier models, uh, especially DeepSeek, which is well known for their open source work. And we're pushing the sort of the frontiers, no pun intended, of the state of the art. So we're getting multimodal capabilities, longer contexts, advanced reasoning, and massive parameter counts. Yet a clear trend has emerged. Open source models are now reaching frontier level performance, often matching or surpassing closed proprietary systems on key benchmarks shortly after release. So this is where open source models were kind of lagging in terms of their quality and their performance, but now they're catching up to the proprietary models, which of course is for the proprietary model companies or the proprietary models themselves is sort of a threat because the whole premise of a proprietary model is it's going to make people a lot of money, and at least the premise behind open source models is that they're free to distribute and you can modify them as you want, which is, of course, maybe anathema to some companies. So when DeepSeek released their open source capabilities, people started freaking out because, for obvious reasons. So this is not slowing innovation, rather it's accelerating it globally. And that's the point that they're making here is that open source shouldn't be seen as a threat to innovation. It actually should be seen as an accelerant to innovation. So that's, again, there are a lot of opinions there. And, I'm of the opinion that open source accelerates innovation and is good in general. So, releasing open source versions of frontier models is not simply generous, it is strategically vital for the long term advancement of AI. Again, I agree with that statement. I think that's a good statement. Recent advances show open source models achieving parity with closed frontier systems in reasoning, coding, and multimodal tasks. Between late 2024 and early 2026, open releases like DeepSeek R1, QN3 235 billion parameters, and Meta's Llama 4, which Scout and Maverick are included in that. The first natively multimodal open weight models and Mistral Large 3 have reached top leaderboard positions. So all these open source variants have, done well in terms of performance. And these are also QN is also widely available in a lot of the desktop implementations of different types of models. So if you're doing things with Olama, or you're doing things with text to video or text to image, you're able to use open source models, even modify them as need be, and run them on your desktop or laptop. Studies indicate open models often launch around 90% of closed model performance, up through community fine tuning and optimization, or they catch up through community fine tuning and optimization. So, the open models are pretty competitive with closed models. They're a little bit behind the curve when they're first released, but then their communities work out the kinks and make them nearly competitive. This convergence shows open source is not a compromise, it is rather a multiplier. So the more community involvement you have, the more use you have, the greater these models become. So it's like kind of a premium on innovation, the open source community being a premium on innovation. And so the core benefits of open source frontier models, and when we talk about open source, what do we mean by open source? In some cases, it's an open weight arrangement where you download the weights, you can modify the weights, or you have access to the weights. Or you have fully open source releases where it includes the weights, the architecture, and the training data details. And so, depending on the model, we have different ways that they're open source. And these, the flexibility of this kind of approach offers advantages that closed models cannot match at scale. And their point here is that accelerated innovation occurs when thousands of researchers, startups, and independent developers experiment, fine-tune, and build derivative models. This creates an ecosystem of specialized models faster than any single lab could achieve. So in a community, you might have 5 or 10 different variants of a certain model. Democratized access also allows smaller organizations, academics, and developers in emerging markets to run frontier-capable models on premises or via affordable cloud infrastructure without API fees or rate limits. This levels the playing field. Enhanced safety and alignment come from transparency. Community auditing helps identify biases, vulnerabilities, and misalignment risks that proprietary black boxes often miss. And this is one of the problems with proprietary models. It is indeed that black box where we don't know what the weights look like or what the architecture looks like. So it runs kind of afoul of some of the AI ethics standards that we're trying to develop. And of course, we have a lot of economic and practical benefits to, people who are deploying systems in their organizations, or they're trying to use them in a practical sense. So this includes lower deployment costs, customizable privacy controls, and rapid iteration. So we can iterate on the models, we can customize what we want in contained in the model that we're using, and we can deploy these models more easily. Now, lower deployment costs, that's totally dependent on the kind of support that maybe a certain model community receives, because you can open source a model and it might be very hard to deploy, simply because whoever releases the model doesn't really think through the deployment process. On the other hand, you can also have communities where deployment is very easy, and in fact much easier than in a proprietary model. So, if we're thinking about the DevOps loop, we're talking about the ops part of this. The dev part, of course, is the part where we're developing these open source tools, and we need to synchronize those together. So let's give some real world examples. Thinking about something like MetaLlama 4, which enables natively multimodal innovation with massive context windows, which gives us greater flexibility for inputs and prompts, powering open progress and vision and language tasks. DeepSeek R1 and QN3 demonstrate global contributions by topping charts in reasoning and efficiency. Mistral and community-driven efforts show mixture of experts architectures dominating open leaderboards. XAI's Grok series highlights how open releases can foster transparent, truth-seeking AI development. These models are not lagging, they are often the foundation for the next breakthroughs. And so, we think about the potential here, but we still have to admit that a lot of closed models are very polished and, in fact, have the sort of enterprise cachet where, open source models do not. And so this allows us to sort of view those, or sometimes people view those as sort of the gold standard, perhaps maybe erroneously, but they do have a lot of good features, and there's a reputational aspect to it. Concerns around misuse and irresponsible releases are valid, which is why responsible licensing and usage restrictions are increasingly common. So this is, the part of open source that can also be reputationally harmful, which is where if the licensing terms are not worked out in advance or usage restrictions aren't spelled out in advance, you can have serious problems. This is one of the problems that we've had in the past with generative AI, with generative image models, where they would not really have the proper license. Eventually, licensing caught up with the technology, and we had better licenses. But in their formative years, you might say have a generative AI tool, and you adopt a standard open source license, and it doesn't necessarily cover the things it needs to cover. So this is just a point of like policy catching up with the technology. But also, the community and the developers thinking through the restrictions they actually want to put on the models. So one caveat about concentrating frontier AI within a small number of closed systems is that it risks slowing the broader progress of the technology, enabling monopolies who control the technology, and limiting diverse perspectives in AI safety research, as well as diverse use cases. And so then they make the argument here for why open source versions fuel overall AI advancement. This is just to say that open frontier models create a rising tide and that the AI race is not zero sum. In other words, there's a role for proprietary models and there's a role for open source models. All right, so that's that article. And it sounds like we had some comments in the chat, so let's take a look. So Barshan says the Fable 5 Anthropic model was put down by the US government. It was capable of giving novel chemical, biological, radiological, and nuclear weapons and ideas. So yeah, there's a lot of times, national security concerns. The Chinese models, of course, there are always concerns about in say the United States about Chinese models, and there are other people who are worried about American models becoming predominant. They don't want to be dependent on American technology or American governmental restrictions and things like that. And so there's this national security geopolitical issue. There are also issues with what kinds of information they give people. So, we don't want to have people accessing, well, this is the thing with search engines. We don't want to have people accessing certain types of information, figuring out how to do things like build a, a terrorist weapon or something. And so that's again a concern. That regulation really, the regulatory space there is very unknown, because it's like, how do you regulate these models? Do you shut them down? Well, no, of course you don't want to shut them down, and you really can't shut them down. But you also can't know exactly what the challenges are until they happen. So that's kind of, I think, an interesting point there. Jesse says, wasn't that the original aim of OpenAI? Oh, you mean being open source? Yeah, I raised the point in the Slack once that OpenAI is neither open nor AI discuss, which is clearly AI, but like you have to go through an API as opposed to just kind of using it at your freedom. So it's a yeah, I mean that's the idea. In a lot of open source organizations, there's this. We talked about open washing last year, which was this idea that a lot of companies will adopt an open stance, but it's only in sort of a marketing sense. Like they say, well, we're open, we have open source values, or we value open source, and then they do a lot of things to sort of make the proprietary aspects as a priority for their organizations. So I don't want to name names, but oh, Jesse, do you have
Oh,
something?
go ahead. I'll come in. I'll come in when we're at the end of the comments.
Okay, yeah,
Sorry.
yeah. All right, it's fine. And it looks like Sarah's here. Hello, Sarrah.
Hello.
Hi, Sarrah.
Hi, I'm audible.
Yeah.
Yep.
Yeah, hi. I haven't been around for a while. I was shifting houses the past month, so I was just incredibly busy. But it's good to be back. I hope to be more regular. Even today, I was not able to join right at the beginning, but a really interesting conversation about open source models. My 2 cents also, I don't know if this was covered, but a lot of times people confuse free and open sourced.
Yeah.
And it's really not the same, especially when it comes to LLMs and data. Because even if you're using, API that is provided by OpenAI, and it gives you the initial kind of tokens free, and you're using it, but it's not the same, because when you are using it, that data is collected by the company whose API you're using, and the model is continuously training on your data. So especially if you're putting it into any kind of system, uh, open source helps you in the way that, because it's hosted locally, one, you are not worried about API costs. So the cost aspect is there, but also in the sense that your data is not going to any server. You have the weights locally hosted. And then another thing would be also, like when you said, right, Bradley, that open source models, even though people consider closed models more polished, open source models kind of help the advancement. And that's really true, because also another thing that happens is that people take these open source models, fine tune them for specific tasks, and again publish those weights that even then other people use. And that's the way that research really works and happens. And I really like that about the AI community, that every company majorly does release mostly open source variants of their models as well. So
Right.
that's good.
Yeah, it's
Yeah.
important, like something like Meta, where they have their proprietary versions and their open
Mhm.
source versions. Yeah.
Yeah. Yeah. Like everybody realizes the importance of like the community kind of working on all of this, right? Because what other incentive would they have to open source their models? If they're providing the free, some tokens on the free chatbot or on the free APIs, anyways. The whole point of open sourcing the weights is for research and advancement. So, yeah.
Yeah. Yeah. So yeah. Thank you, Sarah, for that. And so then I think that it. Yeah, this is Barshan's comment here. These models were never meant to be released to the public. They should have proper policies and audits before beta release since they are too powerful. Yeah, there is this aspect of like making sure before something is released as an open source model that it has like, proper controls on it. And of course, that's goes along with the licensing, which is to say that, your license terms, you don't want people just to use it for anything that they want. You want to have legal controls over it. And the whole point of open source licensing isn't so much that you can stop people in their tracks. It's more like you have legal recourse if they misuse the models. And so that's kind of something that you really have to think through before open sourcing a model. And so then, since we are far from making AI models transparent and interpretable, this could lead to a disaster if misused. Yeah. And I would like to say also that if we don't make our models interpretable, or if we don't go that extra mile to do that work, and that should be what kind of an aim of an open source organization is to have like an interpretability part of the roadmap. That yeah, you can have problems with all sorts of things. And again, licensing can help, but again, people can just use it, and what do you do if they just use it? I mean, the damage has been done sometimes. Sometimes it's just kind of like people do things that are illegal and they don't care. So that's good. And then Jesse says, indeed. And then he says, one of our data and direction interns is interested in looking at the DoD versus Anthropic situation earlier this year, though now over the summer. Yeah, this is all kind of this regulatory unknowns aspect. Okay. Yeah, so that's great. Yeah, keep up that thinking. I like what people are thinking about this. Let me finish up. Yeah. Oh, go ahead.
Well, I mean, I was gonna follow up on some of the regulatory stuff and the guns tech thing, but if you're gonna finish
Well,
up on the same thing or go somewhere else.
I'm just going to do the second article really quickly, and then we can come back to that.
Okay.
All right. So this is a LinkedIn post. So this is a infographic on the new AI economics. So this is something where they're talking about frontier performance at commodity cost. So they're kind of talking about some of the economics of frontier models. So the training costs have gone down, the API pricing has gone down, and but also the market cap for NVIDIA has gone down. Uh, this went down in response to the DeepSeek R1 release. So there are all these market forces at play, these costs that keep shifting depending on what's happening in this space. We have this part understanding the OpenAI spectrum. So again, you have the spectrum of model types from proprietary models, which are more or less a black box, where you maybe get API access, but otherwise can't really audit your models, to an open weights model, which is the new mainstream for or the new standard for open source. And then you have this open weights plus open architecture and full data sovereignty. So a lot of your releases will be along this spectrum. And then so in adopting a model, you need to think about exactly where on the spectrum your model falls, especially if you're using a pipeline of different models. Of course, they have the key players here. They have the technology behind the cost revolution. So making things cheaper is not magic. It's by using different methods and technologies. So they talk about mixture of experts, which is where you have where you route queries of specialized experts, and you in turn cut computational costs. You have reinforcement learning, which is where you have iterative feedback and reinforcement signals, and this reduces dependency on massive uh, labeled data sets by learning from feedback. So that's helping to reduce the cost of these models. And then distillation and quantization, where you shrink models through distillation, and then you reduce the overhead needs quantization for cheaper hardware. So, and then you have the strategic actions for enterprise leaders. So you have reevaluating vendor lock-in. So, this is always an issue for organizations. Do you want to be locked into one vendor, or do you want the freedom to migrate? There's always a cost to migration. There's adopting a multi-model strategy. There's shift the build versus buy calculations. So do you build your own version? Do you build your own frontier model from an open source model, or do you customize that, or do you purchase a proprietary model? Of course, this is weighing data sovereignty, your risks by making one decision or another, and the amount of in-house expertise you have. So sometimes your ops, they're very sophisticated, and so you can take on a model that might require a lot of operations expertise to get working the way you want it. Sometimes you don't have that, and so you have maybe certain open source models aren't available to you as an organization. Okay, so that's my feature. Now Jesse wanted to make some comments, and then I think he wants to talk about public speaking for a little bit.
Yeah, I don't know that I'm going to do the public speaking today, just because having slides will be easier, and I don't have the best. It'd be awkward to do that, so I might table that for another week. But which is fine, it's not a big deal. But I do, on the public speaking note, before I forget, I do think there's sort of a sequence or history of public speaking angle that I do want to cover. And what I previously mentioned was sort of the classic old time things, or like vintage, I think was a fair way to say it. Some of it very applicable now, some of it maybe less applicable, compared with some modern contemporary takes. Um, so to be continued on that, but the thing I said in the chat was essentially around the regulatory space. And I think we all kind of get this here, but one of the things that both for I mentioned one of the data interns were figuring out what they want to do, and it may not entirely be around this, but there's a definite interest in what exactly happened with the Department of War or the Department of Defense and Anthropic in sort of the a few months ago in the March, and the that whole situation, and it extends now somewhat as well, which is sort of ironic that this is about Fable, a particular model, but just that whole arena at a policy level, what does that mean? The thing, the broader comment that I want to say or get at with the guns and technology reference is that I think one of the sort of ways that people make these references about, oh, like industrial revolution, and oh, it's like this or not, compared to these past changes at a level of scale. What's going on is like one of the most fundamental differences is along the lines of what I'm going to try to say next, which is in previous eras of, let's say, political, economic, technological power, like if you were to produce a musket or a gun, you would have to have certain skilled people and certain resources that could very easily be, um, you could kind of see what they were doing. You knew who they were, and they would require very obvious physical things to do what they were doing. And now, the means of production of those things um, was quite different than it is now. So you could regulate, the tea makers, and you could have a statewide, like China trying to keep the secret of how they made certain materials or certain writing or certain things secret, for a long time. it's sort of like, as we've alluded to, the regulatory capacity is really mostly by Anthropic itself. Like the government has some pull here, but we're kind of reaching the limit of what state state versus non-state actors in a very different kind of relationship now in terms of producing models or releasing models. Like there isn't really. I, I, I think there's a lot of debate about this, but if Anthropic or OpenAI or insert other group made a particular model and wanted to release it at that level, like the extremes of that would be what, like having to shut down the internet in some form, which is an option. But there's a very different uh regulatory capacity here. And I think we all know this, so I don't mean to elaborate because we all it's a bit obvious for us. But when people are coming into this trying to understand the space and understand what's sort of going on, like that's the environment that we're in now. So I mentioned many times the FDA regulatory cycle for making new medical device products, 10 years, and how we're kind of inverted that now, where even these wonderful, fantastic institutions like MIT Media Lab and so on are doing, oh, impact. We're going to look at the impact. We're going to train the models. We're going to test this stuff. And it's like, yes, that's nice, but to do, it's there's such a reinterpreting the wake of the event and the aftermath rather than anything ahead of time. So that's where we are. This is kind of standard soapbox and thing that I say about that. I am curious to see where it's going to sorry, this is clicking where it's going to go. But yeah, I'll leave it at that. There's more to say, but I'll leave it at that for now. So I don't know if there's anything else people wanted to cover along that or had follow-ups for that. But yeah, I'll pause here.
Okay, yeah, thanks, Jesse. Yeah, Morgan, go ahead.
Yeah, I was just gonna say, I think, I mean, this is more, EFF and Cory Doctorow, but like, um, the fact that we've not had state regulatory action in the past 30 years doesn't mean that we can't, like
Right.
legally the state still wins, the state still controls Anthropic, the state's, and people like Cory Doctorow would say, it would be a great thing for the tech industry if there was some there was some regulatory action that it would actually be healthy.
Yeah,
Um,
and that's
yeah,
and
and we could, yeah,
and to your point, that's why an immense amount of effort was put into in the United States an attempt to pass some kind of legislation that would prohibit legislation being made at the state level to regulate AI. Like it's if it wasn't a threat if it wasn't a threat, it wouldn't have been something that was tried to be undermined at that level. So yes, like it is a thing, and there are, I mean, and to get away from the American centric view of this, like other countries and groups, even if it's not a perfect, are certainly having a much more proactive or different approaches and different um, incentives about this stuff as well. So
yeah.
um,
It, yeah.
innovation may not come directly here that way from the United States on that front.
It's you know being um, active politically. It is interesting. I met with the um, Attorney General of North Carolina he was here in San Francisco for an attorney general meeting, and it was funny because I was like, so like like, so what do those kind of days look like? Is that mostly you guys all sitting around talking about stuff? And it's like, oh, it's mostly meeting with the people who are afraid that we will be acting in their industries, and it was like crypto companies, um what was it, crypto companies, what do you call, like, polymarket and stuff, like,
Prediction
uh
markets.
prediction market people, pay various shady lenders, and of course tech companies. like 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 all the worst people. Yeah, anyway, I thought that was funny.
Yes.
He didn't say the worst people.
Yeah.
I added that. Yeah,
In a joking way, of course. Yeah.
yeah. Well, it's just like all the people who are engaged in, like, again, like, this is all just straight Cory Doctorow EFFs kind of stuff, right? Which is
Right.
just if you haven't had a business model in 25 years, like, the industry's in a bad shape. You know, um,
Yeah. I think it's interesting. Sarah was mentioning that there's this distinction between open and free. And of course, if you think about free and open source software, that's kind of the thing that people often confuse or don't understand about that is that when it was originally, the term free was originally coined, it was, about free use and opening up the mode of production rather than being free in terms of cost. And so there are a lot of costs we incur, for our different open source projects that is we can still use it for free, but we have to be aware of some of those costs as well. Um, yeah, and then of course with regulation, this is always an open space where you're not only trying to catch up with regulating new technologies, but then the people who have interests in those new technologies, um, want to kind of protect their own interests going forward. Like, people like they feel like that's their right to not have be regulated. This is an old sort of, uh, tech libertarian view where, we don't want to be regulated by government. We want to just develop the technology. So yeah, there's some things in the chat here. Yeah, EFF stands for Electronic Frontier Foundation. They do a lot of advocacy work for free access. And then FOSS is free and open source software. Who was the champion of FOSS that recently passed away? Richard Stallman. I didn't know Richard Stallman had died. He's still alive. Yeah, I thought so. Okay, yeah. So yeah, Richard Stallman was the person who developed the FOSS philosophy. Um, yeah. So that's and so I think there's a lot of conversation here in this space. Um, and yeah, I don't have anything else to say about it though. So did Ed, Sarrah, or Barshan, or Ashu have anything to say? Okay. So I think that's it for today. Thanks to Barshan for presenting on his work. If you want to publish, if you want me to push that blog post to our lab medium, I could do that. I can just take it and repost it if you'd like.
I think it's fine.
Okay.
I'm fine with anything.
All right. Yeah. Just send me a link and I can do that. And then yeah, and I'm looking forward to Ashu's contribution as well. The thing she was talking about. All right.
Yes, I will share the GitHub repo in 2 or 3 days. I will update it and then share it.
All right. Thank you.